All right, welcome to the deep dive. Today we're going deep, really deep,
Deep.
deep into the core of, our digital world. We got some really cool stuff from you. It really gets to like the heart of how things work. Basically, the question is it true that like all the operating systems we use, Windows, Unix, Linux, Android, all that
All
jazz,
the big ones, yeah.
are they really built on C? Like, is C the foundation? That's our mission today, right? To use all this info you sent us to figure that out.
Yeah, and I think based on everything we've seen, the short answer is a resounding yes. It seems like major portions of these operating systems are actually written in C. And it's pretty fascinating when you think about it.
Okay, so C is like this bedrock. But why C? I mean, it's been around forever in computer years. So what makes it so important for something as complex as an operating system? I mean, your sources keep saying power and simplicity, and that's kind of a head scratcher, right?
Yeah.
How can something be both?
Right, right. Well, I think the key here is how C balances those two things. Um, it's kind of like, think of it as having a really, really well-made set of tools.
Okay, yeah.
But you also get like a super clear instruction manual on how to use those tools to build incredibly complex, machinery,
Hmm.
which on OS is, right? It's this really intricate machine.
It is, yeah.
And C gives programmers a ton of control over the computer's like inner workings, its resources.
Yeah.
So you can write incredibly efficient code. But it's not overly complicated, especially compared to some of the newer languages out there. It's this sweet spot. That's what made it so well suited for building something as intricate as an operating system.
Yeah, that makes a lot of sense. It needs the muscle to handle everything an OS does,
Yeah.
but it also needs to be like understandable, right, for all the people who are building it.
Exactly, yeah.
Another thing that kept coming up in your sources is how closely C is connected to the actual computer hardware. Like, why is that so crucial for an operating system?
All right, so if you zoom out a little bit, an operating system's main job is to manage all the physical parts of your computer, right? Like the processor, the memory, your hard drive, all that. And C lets you interact with that hardware on a very, very direct level,
Okay, so it's pretty hands-on.
very hands-on.
Yeah.
And that close connection is super important for stuff like, managing memory efficiently,
Hmm.
deciding which program gets to use the processor at what time, or even, making sure that your printer works. Those are all core functions of an operating system.
So it's like C gives the operating system this like backstage pass to all the machine's inner workings.
Exactly, yeah.
And it's not just operating systems, right? Your sources mentioned a few other areas where C's hardware connection is really, really important.
Right, they talked a lot about embedded systems, like the software that's running inside your car's anti-lock brakes or a smart thermostat.
Oh, right.
In those situations, you need something fast and something that can talk directly to the hardware to get that real-time response. So it makes sense that C is used there too.
Yeah, very cool. Now, let's get into the specifics of these operating systems. Your info actually pointed to specific parts that are written in C. What were some of the key examples?
Well, the Windows API, which is basically the set of instructions that lets all your applications talk to Windows, that's written in C. And then the heart of Windows, the kernel, that's also largely written in C.
Oh.
And then you've got the Unix kernel, which is another major example, pretty legendary in this context. And even Mac OS X, some of the core libraries that make it work are built using C. It's really everywhere you look when you start digging into these systems.
Yeah. And speaking of Unix, because it keeps popping up as this like classic example of an OS built with C, can you give us a quick rundown of what Unix actually is based on everything you read?
Sure. The sources describe Unix as a multi-user, multitasking operating system. So think of it like, a busy office where lots of different people can use the same computer at the same time, all running different programs. That's kind of the idea behind Unix.
Oh, I see.
And the core of Unix, the brain, is the kernel. It's the central command center that manages all the essential stuff, like starting and stopping programs, talking to the hardware, all the behind the scenes work.
So putting it all together, it seems pretty clear that C has had this like huge lasting impact on the biggest operating systems, right? Windows, Unix, Linux, even big chunks of Android and Mac OS.
Absolutely, yeah.
And it's because of that mix of like raw power, but also like relative simplicity and that super important ability to talk directly to the hardware. That's why it's been the go-to language for building these like fundamental pieces of software.
That's a great summary of what we've learned.
It's pretty amazing. And it makes you wonder, right? Because C's been around for so long and it's still so central to how things work. What does that tell us about how we design software?
Yeah.
About the balance between like the fancy user interfaces we see and all that like nitty-gritty low-level control that makes it all possible. That's a really interesting thing to think about.
Definitely is.
Well, thanks for joining us on this deep dive.
My pleasure.
Really appreciate it.
You too.
And thanks to all of you for listening.